Bright Duty. Every student matters.
Okay children, now let us continue with our topic. Now that we know what are ions, what are the valencies or charges that are present in the ions, and we also are aware about the symbols of elements, taking all this into account, we will learn how to write a chemical formula. Now, you must have seen that there are many formulas and you find it very difficult that how would we learn them. You are making an effort to learn them by heart, mugging it up. But today we are going to discuss about how and what is the procedure of writing a chemical formula, on the basis of which you need not mug it up, you can write the formula on your own, and that too it is going to be correct. But before you write a chemical formula, you should be well aware about the symbols of elements. And you should also know the valencies or charges that each of these ions carry. Alright, now let us start with the procedure or the rules for writing chemical formula. What are the basic rules for writing chemical formula? So the rules of writing chemical formula are as follows. The first and foremost, what you need to do is, you need to write down the symbol of the element. So you are going to write down the symbols of the elements. Okay. Next, you need to write down the valencies or charges, or the charges in the ions. So whether it is a cation or anion, you need to know the valencies or charges these carries. The third is, whenever we are writing any chemical formula between a metal and a non-metal, then we always write down the symbol of the metal first and then of the non-metal. That is, we name the cation first and the anion. Alright. So if you need to write down the chemical formula between a metal and a non-metal, then we will always write down the symbol and name it with the metal first and then give the name of the non-metal. So it is always the metal and the non-metal, or the cation and the anion. And as I already told you when we were discussing the anion, that whenever we name the anion, then we do not take the name of the atom, we would rather change it into IDE. That means a chlorine will change into chloride, oxygen into oxide, okay, nitrogen into nitride, so on and so forth. The fourth is, in case we have polyatomic ion, if we have polyatomic ion, in this case, we are going to write down the polyatomic ion together and put it in bracket. That means polyatomic ion should always be written in bracket and then the charge should be put up. So in case if I am writing sulfide, then it is 2 minus. That is, this charge is not only for oxygen but it is also for sulfur. So when I am writing it in chemical formula, we have to make it a point that polyatomic ions are put up inside the bracket to show that they are not individual atoms or ions, they are rather polyatomic ions. So I repeat, when you are writing, you need to know the symbol of the element. We write down the symbols of the element, always in the form of symbolic representation. The valencies should be known. We need to write down the valencies or charge of the ion. If it is a chemical formula between a metal and a non-metal, then we would always name the metal first and then the non-metal, and change the name of the non-metal accordingly by adding IDE. Whereas for every polyatomic ion, we need to put it inside a bracket in a chemical formula to distinguish it from an atom, to specify that it is a polyatomic ion and not an atom or any cation or anion. So let me explain this to you with few examples. Let me consider one example. For instance, if it is hydrochloric, or rather if I have to make it little simpler, then let me take hydrogen chloride. Now the rule says, how do we write it? First we need to write down the symbols. So what is the symbol of hydrogen? It is H. What is the symbol of chlorine? It is Cl. Now then we need to write down the valencies. When we write down the valencies, we write down the valency of hydrogen here. We know hydrogen has a valency of 1, whereas chlorine also has a valency of -1. While we are writing the chemical formula, when we write the chemical formula, then we cross the valencies. That means the chlorine valency will come and get attached to hydrogen, whereas hydrogen valency will come and attach to chlorine. Thereby, hydrogen will have 1 and chlorine will have 1. That is, it is HCl. So this is the chemical formula of hydrogen chloride. In other words, we also call it as hydrochloric acid. Okay, so I hope it is clear to you. First you need to write down the symbols, then put up the valencies, then it is always the metal would be named first, then the non-metal. In this case, you see hydrogen is behaving as a cation because it is in combination with an anion. And I told you that hydrogen is the only non-metal which has this unique property of behaving both as a cation and an anion depending upon with which ion it is reacting. So if you need to write the chemical formula of hydrogen and chlorine, then this is the way. The first step would be you would write down the symbol side by side, then you would write down the valencies and put them crosswise. Then you cross the valencies and you get the chemical formula as this. Alright, now let me try and explain you something else. If I take sodium carbonate, this is my next example. Now again, as the rule goes, you need to write down the symbol. What is the symbol of sodium? It is Na. What is the symbol of carbonate? It is CO3 because it is a polyatomic ion. Next we need to write down the valency. What is the valency of sodium? It's +1. What is the valency of carbonate? It's -2. This is all known to you. What is the third step? So in the first step, we write down the symbol. Second step, we write down the valency. So what is the third step? The third step is you cross the symbols. You cross the symbols. When you are crossing the symbols, the chemical formula would become Na2CO3. Do you remember that polyatomic ions needs to be put up in the brackets? So we are putting brackets. So with carbonate, 1 goes and with sodium, 2 goes. Because carbonate has only 1 as the value, so we need not put it in bracket. We can also write it as Na2CO3, which also means that there is 1 carbon, 1 oxygen. So this is the chemical formula of sodium carbonate. Alright. Next, if I give another example, shall we practice with more examples? For instance, if I take calcium chloride. Now for calcium chloride, what would it be? For calcium chloride, again, let us write down the first step is to put down the symbol. What is calcium symbol? Correct, it is Ca. And what is the symbol of chloride? Cl. Good. Then we write down that of valency. What is the valency of calcium? Plus 2. Valency of chlorine? Minus 1. Alright. So while writing the chemical formula, when I am writing the chemical formula, what would be? The chemical formula would be that I put a cross. When I crisscross it, what would happen? Calcium gets a value of 1 and chlorine gets a value of 2. So if I do not write 1, CaCl2. This is the chemical formula of calcium chloride. So I hope this is clear to you.